All right, so here's your warm-up. All right, so you were supposed to fill in those blanks. Here's the key. Now, if you put transitive property for number 3, that's fine. It is technically the transitive property also, but you could have had transitive or substitution here, okay? Now, thing you really need to be aware of is this right here. Vertical angles theorem only deals with congruence. It does not deal with equality, okay? So never ever say 2 things are equal based off the vertical angles theorem. That would be incorrect, all right? Any questions on this I can address? Anybody's still looking at it? All set? All right, we did these yesterday, so that was for the other teacher. All right, so today we're writing proofs. Take out your companions. I want you guys to turn to page 28. So our ICANN statement is use deductive reasoning to prove theorems. And our vocabulary is paragraph proof, proof, theorem, 2-column proof. Okay. So we're going to skip example 1, go to example 2, and we're going to skip letter B. If you guys take a look here, we're going to apply vertical angles. So what's the one thing we know about vertical angles if we're going to apply them to algebra? You can tell me. Good. They're congruent, which means they're going to be equal, right? So if I want to set this up and solve for x, how am I going to do that? Good. Very good. Someone tell me, what does x equal here? What? 25. And that's it. Okay? So you would just solve for it. Questions on that? All right. Let's move on. All right. So when we are writing a paragraph proof, so we've been doing 2-column proofs. All right. So when you write a paragraph proof of congruent supplements theorem, so angle 1 and angle 2 are supplementary, angle 2 and angle 3 are supplementary, we're going to prove that angle 1 is congruent to angle 3. So another way to write a proof is called with a paragraph proof. In a paragraph proof, the statements and reasons are connected in sentences. So the proof here would be, by the definition of supplementary angles, because you're starting with supplementary angles, the measures of angle 1 plus measure of angle 2 equals 180, and the measure of angle 2 plus measure of angle 3 is equal to 180. Since both sums equal 180, the measure of angle 1 plus measure of angle 2 equals the measure of angle 2 plus measure of angle 3. Subtract the measure of angle 2 from each side of this equation to get measure of angle 1 plus equals the measure of angle 3. By the definition of congruent angles, they are congruent. So this is a bit weird, right? So believe it or not, 2-column and paragraph proofs are interchangeable. So if I kind of just wrote this as here's my statements, here's my reasons, okay? And I started with angle 1 and angle 2 are supplementary. And then I have angle 2 and angle 3 are supplementary. That would be my given. The next part, step 2, would be, okay, well, if they're supplementary, then that measure of angle 1 plus the measure of angle 2 would equal 180. I'd also have the measure of angle 2 plus the measure of angle 3 equals 180. And that would be by the the definition of supplementary angles, right? Step 3 here would be that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3, since they are both supplementary. And you would do that by, would be a substitution property. Or transitive, both work. I'll continue over here. Step 4 would be if the measure, if we subtract the measure of angle 2 from each side, we have the measure of angle 1 equals the measure of angle 3, and that's by subtraction property of equality. And then last but not least, step 5, we would state that the measure of we would state that angle 1 is congruent to angle 3, and that would be by definition of congruent angles. Now, both of these proofs are the same. So if you really want to, you can start with a 2-column because that's what you're going to see most anyway, I'll be honest. And then just put it in words. I'm going to show you how to do that next. Okay? Any questions on this? Here is the one, you know how everything's nitpicky, right? Here's the one nitpicky part about paragraph proofs. You guys see how I'm like kind of, let's see, what would we call that? Condensing a little bit here, right? I'm not fully spelling out supplementary. I could put sub, right? In a paragraph proof, you have to write it word for word. Okay? You can't use the congruency symbol. You need to write out congruent. Okay? Does that make sense? Okay. So let's take a look at example 3. All right. So looking at this, I am first going to write my proof. All right. I'm just going to write my 2-column. Now they're saying they're complementary. So my step 1 is going to be angle 1 and angle 2 are complementary, and angle 2 and angle 3 are complementary. That is what is given to me. Step 2 is going to be, all right, well, if they're complementary, then their sums are 90 degrees, right? So I'm going to have the measure of angle 1. Sorry, it's not like the best here, guys. Sorry. Plus the measure of angle 2 equals 90 degrees. And the measure of angle 2 plus the measure of angle 3 equals 90 degrees. That's by definition of the complementary angles. Now, if they're both equal to 90, then I know that these two are equivalent to each other, right? So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. That's by substitution property. Bless you. Step 4, I subtract the measure of angle 2 from each side, leaving me with the measure of angle 1 equals the measure of angle 3. So, and that is by subtraction property of equality. And then last but not least, step 5, we have angle 1 is congruent to angle 3, and that is by definition of congruent angles. All right. So does it make sense where this 2-column proof is coming from? Okay. So since this makes sense, now all I have to do for a paragraph proof is put that in words. My ideas are organized. So what I'm going to do is I'm just going to write it out, given angle 1 and angle 2 are complementary, and angle 2 and angle 3 are complementary. All right. We can state that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. And the measure of angle 2 plus the measure of angle 3 equals 90 degrees by the definition of complementary angles. Notice how I'm still color coding this so you guys see like the wording, okay? And then I could put by substitution property of equality, the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And then using the subtraction property of equality, I can state that the measure of angle 1 equals the measure of angle 3. And then lastly, by the definition of congruent angles, I can state that angle 1 is congruent to angle 3. So you guys see how they relate? Let me give you a minute to write this down, if you didn't already, because this is kind of what we're looking for. Now, if you kept saying, instead of like, we can state, you could say, okay, given this, then by the definition of complementary angles, these two, angle 1 and angle 2. You just got to make sure you mention the rule. You got to make sure you mention the statement. You got to make sure it's relatively legible in English. All right. Out. So this is how they relate. Now, if you're the type of person that likes writing in words first, you can flip-flop it. Write it in a set, write it in paragraph, and then put it in 2 column. Okay? You're going to be seeing 2 column the most, but paragraph proof has its place too. Show hands, you're still writing. Go ahead. What's that? You done? Anybody else? Okay. So let's move on. Oops. Here we go. All right. So this is just an example of a 2 column proof. All right. This says that the measure of angle 1 is equal to the measure of angle 2, and the measure of angle 1 is equal to 105. Prove that the measure of angle 3 is equal to 75. All right, so if we take a look here, this and this are congruent, right? So I would just write that in. This is not in your this is not your try it. This is just from the book. All right. So this and this would be congruent. And then they're stating that this first angle is 105. All right. So if I have the measure of angle 1 is equal to the measure of angle 2, that's given to me. The measure of angle 1 is equal to 105. Therefore, by the transitive property, the measure of angle 2 has to be 105 as well. Does that make sense where that's coming from? Okay. Now, we're trying to prove that angle 3 is 75 degrees. So what we're going to do is we're going to state, hey, 2 and 3, these guys right here are a linear pair. And that's true because they have that adjacent ray and they're forming that straight angle, right? So we would state that they're a linear pair by the definition of a linear pair. And then because of that, this angle plus this angle equals 180 by linear pairs theorem. Now, we have the measure of angle 2. So we're going to take that, we're going to substitute it in. We're going to subtract the 105 from each side, leaving us with the measure of angle 3. That gives us measure of angle 3 is equal to 75 degrees. That is what we were trying to prove. And we did that through the subtraction property of equality, so we're good. Do we have to use the symmetric property here? No. Remember, symmetric property does that flip that might be required. It depends on how you set it up. Questions on this? All right, let's take a look at this one. So this is the try it on page 29. Notice the change. They wanted you in the book to prove the measure of angle 1. We're going to prove the measure of angle 3. We're just going to prove the measure of angle 1. All right. All right. So again, this is going to be a 2-column. I'm going to have my statements. I'm going to have my reasons. So the first thing, now I am going to split the given like we did yesterday with that last problem. Okay. For me, it's just a little easier. So for step 1, I'm going to have the measure of angle 4 equals 35 degrees. Okay. And that is given to me. Now, the well duh moment would be what here? Who can tell me? If angle 4 is 35 degrees, then what does angle 2 have to be? 35 degrees. But we have a problem. If we just went straight into that step, what would be our reasoning? And you can't say vertical angles theorem. You also can't say definition of vertical angles, because the definition defines what vertical angles are, but not what happens after they're considered vertical. Do you guys see the issue here? You can't just jump into, hey, the measure of angle 2 is 35 because they're vertical angles. No. So here's what's going to happen. The first thing I have to do is I have to state that angle 4 is congruent to angle 2. That is by the vertical angles theorem. Because if you look back at vertical angles theorem, all it states is that they're congruent. It never states anything about equality. However, this leads me to the next step where I can state, because those two are congruent, I can do the measure of angle 4 is equal to the measure of angle 2. All right, and that would be by definition of congruent angles. Does that make sense where that's coming from? That's actually very important. We're going to do the same thing when we get to perpendicular stuff too. We can't just state a right angle, our perpendicular lines have automatically 90 degrees. There's some glue in between. Okay. Consider this the glue for vertical angles. All right, so now that they're defined, right? Now can I state that the measure of angle 2 is equal to 35? Yeah, I can. So I'm going to state that the measure of angle 2 is equal to 35 degrees. Oops, sorry, that's step 4, not step 5. Oopsie. What's the reasoning? Substitution works. What's another one? Both work, so I'm good with the other one. What's the other one? Begins with a T. Transitive property, yep. Just be careful with transitive property a little bit, guys. The only reason I'm a little pickier on transitive property right here is because we have 4 is equal to 2, 4 is equal to 35, therefore 2 has to equal 35. So that's very boom, boom, boom. However, you can call this substitution property too, but you can't not all substitution is transitive property. Does that make sense? You have to have the 3 parts and 2 of them have to match for the transitive property. But when you substitute in, it's not always going to match like that. Okay. All right, part 5. Now that we have measure of angle 2 is equal to 35, I'm going to work on my second given. And that's this guy right here. So the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 4. That's just given to me. So now what am I going to do? I'm trying to prove that the measure of angle 1 is equal to 70 degrees. What can I do here? Good.
You can substitute measure angle 2 and measure angle 4 to 35.
Perfect. So the measure of angle 1 equals 35 plus 35. Step 6, that's substitution property. Notice how I cannot use transitive property here. Do you guys see the difference? Okay. This one is, oh my gosh, no. Oh, I did not even touch that. What the heck? Sorry, guys. This one is this is equal to that. That is equal to this. Therefore, those two have to be equal. This one is just, hey, I'm taking these and putting them in. Okay. So be careful. All right. Step 7, I have the measure of angle 1 equals 70 degrees. What's the step there? What do we got? Simplify. Yep. What was another way of stating that? Come on, my turn. Questions on this? All right. That's it for this. So is anybody still writing it down? All right. Now, there is something I want to bring to your attention, but before I do, let me stop the video. Have a great day.